In the last video, we learned how to convert between polar points and Cartesian points. And in this video, we're going to convert between polar equations and Cartesian equations. So we'll be given an equation in one of the forms and trying to get it into the other form. So we're going to use the same four identities as before. X equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and tangent of theta equals y over x. This will be kind of like the identity section from your trig class, where you were trying to prove that things were identities, except in this case we're going to use these four identities only and try to convert from r and theta to x and y. So from polar to Cartesian, we want to replace the polar equation with an equivalent Cartesian equation. And remember, Cartesian always means x and y. And we're given the equation r equals 4 tangent of theta times secant of theta. Now I know that tangent of theta has the identity y over x, and so I know I can replace the tangent of theta easily. I can't replace secant of theta very easily, but I do know that secant is 1 over cosine, and so I could rewrite this equation as r equals 4 tangent of theta times 1 over cosine. And now what I recognize is that if I multiply both sides by cosine of theta, then on the left-hand side of the equation I'll get r cosine of theta, which is equivalent to x. So I'm going to multiply by cosine of theta. I get r cosine of theta equals 4 tangent of theta. And I have neat replacements for both of those. R cosine of theta is x and tangent of theta is y over x. So I replace those and get the equation x equals 4y over x. Now, what I'd prefer to do is get an equation in the form y equals a function of x. And so I'm going to multiply both sides by x. So x squared equals 4y. And now divide both sides by 4. So my final equation is y equals 1/4 x squared. So I know that that equation, whether it's written in polar or Cartesian, is going to look like a parabola. So we're still going from polar to Cartesian, and we want to replace the polar equation with an equivalent Cartesian equation. We're given r equals 5 divided by the quantity sine theta minus 2 cosine theta. Now what I recognize in this one is if I multiply both sides by the denominator, then I'll get my first two identities, which is r cosine theta equals x and r sine theta equals y. So I multiply both sides by sine theta minus 2 cosine theta, and I get r sine theta minus 2r cosine theta equals 5. And now I replace r sine theta with y and r cosine theta with x. So I get y minus 2x equals 5. Solving for y, I get y equals 2x plus 5. So I know this is a line in my xy plane, whether it's written in Cartesian or polar. So the r equals 5 over sine theta minus 2 cosine theta is equivalent to y equals 2x plus 5. So we're always looking for a way to manipulate our equation so that we can use one of the four identities that we're given. Alright, in this example we have r equals negative 2 cosine theta plus 2 sine theta. And the identities I'm given are x equals r cosine theta and y equals r sine theta. I know those are what I'm trying to use in order to replace my, my theta and r. But I don't have a nice way of getting my polar equation into this form. So what I'm going to do is solve each of these identities for cosine theta and for sine theta. So x equals r cosine theta becomes cosine of theta equals x over r. And y equals r sine theta becomes sine theta equals y over r. So I'll replace the cosine theta and the sine theta in my polar equation. So I get r equals negative 2x over r plus 2y over r. And I multiply both sides by r. So I have r squared equals negative 2x plus 2y. And now I have a straightforward replacement for r squared. It is equal to x squared plus y squared. So I have x squared plus y squared equals negative 2x plus 2y. And I can recognize from Unit 1 that this is the equation of a circle. And so what I want to do is get it into the standard format for the equation of a circle. So I'm going to complete the square. So I move all of my variable terms to the left side. So I have x squared plus 2x plus a blank, because I'm going to complete the square for the x's, plus y squared minus 2y plus blank, because I'm going to complete the square for y, equals 0, because I moved the minus 2x plus 2y to the other side of the equation as plus 2x minus 2y. So now I do my 2 over 2 squared equals 1. So I'm going to add 1 to the x terms and add 1 to the right side of the equation. Completing the square for y, I'm going to do negative 2 divided by 2 quantity squared equals 1. So I add 1 to both sides of the equation. And now I can factor my perfect square trinomials. So I get x plus 1 quantity squared plus y minus 1 quantity squared equals 2. And I know that this is a circle with center negative 1, 1, and radius square root of 2. Remember, your center always has the opposite sign of what you see in the equation. So that's going from polar to Cartesian. Now we want to go the other way. Given an equation with x and y, we want to change to r and theta. So we have the same identities, but now we're going from Cartesian to polar, and we want to convert the Cartesian equation to a polar equation that expresses r in terms of theta. We're given x squared plus the quantity y minus 2 squared equals 4. Now, I know I could just start replacing the x and y with my r cosine theta and r sine theta, but what I recognize with this is that if I actually FOIL out the y minus 2 quantity squared, then I'm going to have an x squared plus y squared in my equation, which I can replace a little more easily with r squared. So I'm going to expand first so that we can use the x squared plus y squared equals r squared identity. So I FOIL out the y minus 2 quantity squared, and I get x squared plus y squared minus 4y plus 4 equals 4. The 4 on the left and right side of the equal sign cancel each other out, and the x squared plus y squared gets replaced with an r squared. Y is equivalent to r sine of theta, and so I end up with r squared minus 4r sine theta equals 0. Now I'm going to factor r. So I have r times the quantity r minus 4 sine of theta equals 0. And I know from the zero factor property that this tells me r equals 0 or r minus 4 sine theta equals 0. So this tells me that my equivalent equation is r equals 4 sine theta. So we're always trying to figure out the easiest of the identities to use. And notice in our 4 examples we used all 4 of the identities. So you always just want to think a little bit ahead, think a step ahead, and try to figure out which one is going to be easiest in order to replace your r and theta with x and y, or replace your x and y with r and theta, depending on which direction you're going.